You can make a new data asset by subclassing UDataAsset. To instantiate a data asset, right-click under Miscellaneous, choose Data Asset. Then we pick the type of the data asset. I've called it My Data Asset Spawnable Information. Data assets are actually singleton-like objects. All references of a data asset instance point to a single location in memory. You can also subclass a code data asset class in C++. Just inherit from your custom code data class. If you create a new subclass, you can convert existing data assets to the new subclass. Right-click and convert to a different data asset type. Then I'll pick the new code child subclass. Now we need something to use the data asset. I'll make a new spawner actor that has a reference to a data asset. Let's override the virtual function notify actor begin overlap. And when that overlap happens, we will spawn an actor. So different data assets can spawn different actors. This will spawn actors from the data asset properties set on the spawner. We can see the spawn spheres above the spawners. But notice the data asset pointers, they're all the same, ending in address 3540. As a reminder, generally prefer for declaring in the header and including CPP files. Note that data instances do not support data inheritance. And that's really a feature of data assets. The data assets kind of enforce that these are kind of atomic data units. There's the data asset class, which defines what variables are available on the data asset instances. And there's the data asset instances, which just put data into those variables, but can't add or remove new variables. To make a data asset class in Blueprint, generally use subclass via the Blueprint classes. Just name it DASC for Data Asset Subclass. Notice it has a different color in the asset icon. It is a bluish color, whereas the actual data asset instances are a reddish color. We can add a new variable that we can use in data asset instances. To make an asset intended for data population, we again go to the option under Miscellaneous to create a data asset instance. Just have it spawn the alternative actor. But let's also populate the variable the Blueprint added. I'll just put some nonsense string into this variable. Spawn actors, the spawners are able to read the fname string we added in Blueprint. We can see that the Blueprint extended data asset is given a unique singleton object in memory, its address ending in 3480. It is also a singleton, just like our code-defined data assets. How to make a new data asset in code. You can make a new data asset by subclassing UDataAsset. For this example, we will build a spawner that uses a data asset. The data asset will inform the spawner what actor it should spawn, allowing us to update the data asset without updating all the spawner instances in a level. We need some data in our new data asset. Let's define a class to spawn that users can set in the data asset. Subclass lets us specify a class in the editor, and we can use that class when spawning an actor into the world. We can use actor subclasses to constrain what is selectable in the editor, so I'll make a new actor called visual only actor to spawn. I'll define the class above the data asset. Generally, I'd make a new file for a new actor type, but putting it in the same file is fine for demonstration purposes. We need to expose our data asset properties to the editor with uProperty. I'll just set it to edit defaults only because conceptually we don't really want anyone changing the data assets in the level instances. So edit anywhere is inappropriate. This means designers will have to open up the data asset file to change the data. We'll expose it to Blueprint scripts by setting it to Blueprint read only, since Blueprint shouldn't really be overriding data defined in the data asset. Now we need something to use the data asset. I'll make a new spawner actor that has a reference to a data asset, and it spawns whatever is defined in the data asset. We'll set a large overlap volume around the spawner, and when something overlaps it, it will spawn the actor from the data asset. So let's override the virtual function notify actor begin overlap. And when that overlap happens, we will spawn an actor. Before we spawn, we'll add a check to make sure it hasn't already spawned something. Just a raw C++ bool member variable in the spawner class will do. We also need to have a property on the spawners which specifies which data asset to use. Since we could have multiple different data assets with different data, this lets a spawner be configured to a specific data setup. We'll make it a uProperty. Level designers might place the spawner actor directly into a level. It would be nice if they could just place one spawner actor and change the data as needed. So we should make the data asset property instance editable, but it also might be nice to have a pre-configured spawner so we won't edit defaults only as well. So we'll just specify edit anywhere to cover both workflows. That being said, we don't want Blueprint script changing the data asset at runtime, so we'll just make it Blueprint read only. Now it can read the data at runtime but not change it. For sake of demonstration purposes, we'll make a hard reference with t object pointer. We'll only spawn if there's a spawned data asset set. So let's add that to the check. Let's grab the world pointer so we can spawn an actor in the world. There's various spawn actor overload functions. We'll use the one that takes a transform. Let's specify the transform to be over the top of the spawner actor to keep this simple. So we can just get the actor transform as the base transform and add a bit to the z value of its location, since z is up in Unreal. Now we can just set the spawn location in the transform to the calculated location. Now let's pass a class as the first argument to the spawn actor function. We just read this data from the data asset we're creating. There's an additional argument needed. It is of the type fActorSpawnParameters. We can leave it mostly empty, but we need to provide it for the function. So I'll just create an empty one on the stack and pass that to the third argument of the spawn actor function. This overload of spawn actor function is a template. So let's specify the base actor type we're spawning. It's fine that it isn't a blueprint type. The spawned actor can be a child of a template parameter. Note that if we had not made our own C++ actor type, we could just use a actor as the template parameter. After we spawn the actor, let's log that we spawned it. This is just to help debugging and see specifics about the data asset pointers. We can just log the pointer addresses for demonstration purposes, but in a real game we would actually log the names of the asset, not the addresses. You can call getNameSafe function and pass in a uObject to get a readable name. Data assets are actually singleton-like objects. Logging the pointer address will make this singleton behavior apparent. All references of a data asset instance point to a single location in memory, which means if you modify a data asset anywhere in a level, at runtime you're affecting everything that is currently using that data asset. Generally, this is not what you want from a data asset. Data should be constant. Let's get this compiling. I believe I need to include t-object pointer to use it. I'll just do a text search for the file name ending with .h and see where someone else included it. I'll go ahead and include UDataAsset as well. We need the complete type since we're inheriting from it. A for declaration isn't enough when inheriting from a type. Though sometimes it can compile initially when it brings in the include from somewhere else, it's best to include what you are using. Might as well also include actor instead of relying totally on core minimal.h. I generally try to avoid core minimal.h in real game code and include directly what I need if I cannot safely for declare it. As a reminder, generally prefer for declaring in the header and including CPP files. In the CPP file, I need to include the file that defines the type uworld. I put this in the CPP file because the header doesn't need to know about the uworld type. As a quick check, I just do a text search to see what other files included world.h and see how it should look for my include. Now with everything included, we can log the data asset pointer. I'll just call .get to get the raw pointer address. First, we will create an actor to spawn in the world. We will set this class in the data asset. We'll just subclass our code named visual only actor to spawn. Right click, create blueprint class, and set it to visual only actor to spawn. Let's add a sphere to give it some visual representation, set a material on it so it has some color, then I'll duplicate it to make other actors with a different color. So different data assets can spawn different actors. Now that we have some actors to spawn, let's make the data assets. To instantiate a data asset, right click under miscellaneous, choose data asset. Then we pick the type of the data asset. I've called it my data asset spawnable information. I'll give the content asset a name. We can open up the asset to populate the data. I'll set our BP class visual only actor in the first data asset. Let's make another data asset and set the other actor class to be spawned. In the alternative data asset, let's set the other actor class to spawn. Next, let's make a spawner subclass we can place in the level, which will use the data asset to spawn actors. I'll make a new blueprint class and choose the parent class to be our spawner code class. I'll just name it data spawner. Let's add a cube so we can see the spawner in the level for testing, and give it some color with a material. Now we can set the default data to spawn here in the details panel. I'll just set it to the main data asset. We need something to trigger an overlap to kick off the actor spawn. We can add a box collision to the actor and set it to the appropriate size. It would be better to change the box extents, but I just scaled it for a quick demonstration purposes. We can drag and drop the spawner into the level, hold Alt to duplicate them to make multiple spawners. Now I'll test it by starting Pi, and I'll fly my camera through the overlap volumes, which will cause them to trigger our C++ code handling overlaps. This will spawn actors from the DataAsset properties set on the spawner. We can see the spawn spheres above the spawners. If we go back to the IDE, we can search the log to see our logged information about spawning. We logged each spawner's pointer address and the address of the data assets used for spawning the actor. We can see each spawner has a different address. They're ending in E600, 9100, and F00. Each spawner has a unique location in memory. But notice the data asset pointers, they're all the same, ending in address 3540. This is what I mean by data assets or singletons. Data assets are shared memory because they're not really intended to be modified at runtime. In my opinion, it's meant to be a place where you read data from, not write data to. Because if any spawner did write to the data asset memory, it would be writing memory used by all the other spawners. In that scenario, it is likely that multiple spawners would clash with each other in an incomprehensible way. There's nothing stopping you from potentially writing some code to do this in C++, but you should think very careful before doing that, since it's not really the intended usage, from what I can tell. While I didn't do it here, it is probably a good idea to make your data asset variables const to discourage other coders on your team from modifying them. If you want something modifiable at runtime, then perhaps a subsystem or game state component instead of a data asset. Anyways, let's make some spawners that spawn our data. Select all these to duplicate using Alt-Drag. With all of them selected, I can update their data properties at once. Just go to the Details panel view in the level and set the data asset property to another value. This will update all the selected level instances to hold a pointer to the alternative data asset. Now, we can pi to test the new spawners. We can see they're spawning a different actor based on its color. If you select individual actors, you can see the instance variables are different. When you set edit instance only on a U property, this is what it's referring to. I'm not sure if this is official or terminology, but my mental model of data assets has two related concepts: data classes and data instances. There's the data asset class, which defines what variables are available on the data asset instances. And there's the data asset instances, which just put data into those variables, but can't add or remove new variables. So when you subclass UDataAsset, you're defining the data asset class. When you create a data asset under the miscellaneous view in the editor, you're making a data asset instance. Again, I'm not sure if that's official terminology, but that's how I think about them. Blueprint can also create data asset classes via Blueprint subclasses. Blueprint can also extend a code data asset class rather than just populating data. What we've done so far is use a code data asset class as a template for data. But in Blueprint, we couldn't add any variables, we could only set them because we were making a data asset instance. To make a data asset class in Blueprint, generally use subclass via the Blueprint classes. Ideally, we use a Blueprint data only class in this case. But if we try to subclass our code data asset via Blueprint class to add variables to it, you'll see it isn't in the list of actors to subclass. This is because we have to opt in our data asset for Blueprint subclassing in C++. So let's close down the editor to fix that. Our data asset needs to be flagged with Blueprintable in the uClass macro. Now if we recompile with that change, create a Blueprint class, our data asset is available in the list of classes to subclass. To disambiguate it from data, I'll just name it DASC for data asset subclass. Notice it has a different color in the asset icon. It is a bluish color, whereas the actual data asset instances are a reddish color. This bluish color means we're defining the data asset class rather than an instance. If we open up our data asset subclass, we get a full Blueprint editor. If I close it and open it again, we get the data only view. However, to add variables, I'm not sure how to do this from the data only view, so we'll go back to the full Blueprint editor view, being careful not to add anything to the event graph or functions. We can add a new variable that we can use in data asset instances. I'll just add a name variable, and we can have our spawners print out that name value if the data asset is of this subclass type. Now we want to actually make a data asset using our new data asset type. To make an asset intended for data population, we again go to the option under miscellaneous to create a data asset. We'll use the data only Blueprint subclass this time instead of the code class. I'll name this DA extended via BP to make it obvious this has the extra data in addition to what we provided in the code class. We can open up that new data asset. In regards to the code property, let's just have it spawn the alternative actor, but let's also populate the variable the Blueprint added. I'll just put some nonsense string into this variable. There's a typo in the variable name. I can go back to the Blueprint subclass and fix the typo in the variable name, and it updates in the new data asset as well. Now for example, I'll just duplicate our spawner class to show how to read the custom Blueprint variable data. even when the variable type is of the code data asset, not the blueprint data asset. The spawner variable type is for the code data asset, but since the blueprint data asset is a subclass of that, we can still populate the blueprint data assets into this field. For the spawner, I'll change the color to blue to make it obvious we're dealing with the blueprint version of the data asset. Also, I'll have it do logic reading the data when an overlap happens. Let's get the data pointer, which is of the base code class, not the blueprint class we created. I can then cast it to our DASC type, the blueprint subclass of the data asset. I'll print out if this cast failed for demonstration purposes. If the cast succeeds, I'll print out the f name that we set in our blueprint extended variable. Now we can drop the spawner into the level and see it working. Currently, all of them should have data assets of our code type, so all the casts will fail. We can pi and test the cast failure logic. If we go into the spawner and update the data asset to be our blueprint extended type, we'll see a different result. We can type DASC prefix on the type to filter it if we're unsure what is the appropriate data asset. Let's test again in pi. We can see as we spawn actors, the spawners are able to read the fname string we added in blueprint. This means the cast is succeeding. Let's see what the pointer address looks like in this setup. I'll clear the output to make it easy to analyze. Now pi and fly through the spawners. We can see that the blueprint extended data asset is given a unique singleton object in memory, its address ending in 3480. But it is also a singleton, just like our code-defined data assets. For example, one of the code-only data assets is ending in E880. So each data asset instance is getting its own memory address. So we can see even blueprint-defined data asset instances are singletons in memory. Additionally, because our spawner is using the code type for its property, we can swap out for a data asset of the parent code type, and spawning still works with this custom spawner type, because blueprint inherits from the code type. We can see here that it is able to spawn from any of the data assets, but only one cast will succeed, the one using the blueprint type. One last thing I wanted to mention. You can also subclass a code data asset class in C++. You just inherit from your custom code data class. If you create a new subclass, you can convert existing data assets to the new subclass. To demonstrate that, I'll add a new fname variable in code. Then in the spawner, I'll cast the data asset and read the variable. I'll log it for easy testing, compile that and boot the editor, then find a data asset I want to upgrade in the content browser. Right-click and convert to a different data asset type. Then I'll pick the new code child subclass. If we pi, we can see that the casting of the data asset works, and it is still spawning an actor. If we open up the data asset and set data into our fname field, that data can be read when we pi. Testing pi again, we can see it logged what we typed into the editor. Note that data instances do not support data inheritance. If you right-click and go into miscellaneous data asset but hover, you get a tooltip that tells you that if you want data inheritance or a complicated hierarchy, data-only blueprint classes should be created instead. If we actually tried to use data inheritance with DA spawn main, we'll see that it's not selectable to instantiate for this data asset. But the DASC, which is a data class or subclass in Blueprint, we can extend that and create a new subclass. But when it comes time to actually populate the data, you make an instance, it's not inheritable data. And that's really a feature of data assets. You don't have to use that, you could just use Blueprint classes everywhere, but the data assets kind of enforce that these are kind of atomic data units. So since you stayed around this long, here's a pro tip for modifying multiple data assets at once, since data inheritance isn't allowed. You have to select the data assets to modify all at once, and a quick way to select them from multiple folders is to click on this all above content, turn on a data asset filter, and type what you need to select the relevant ones. And so what I'm going to do is select all of the data assets from this video, and I'm going to right click on those and go to Asset Actions. And then in here, it's Edit Selection and Property Matrix. So what this does is it shows you all of the assets in a different type of view. You can change the variables here. It's a little bit more constrained, but for this, I've made 3 new assets that are prefixed with test, and I just want to change them to be a single actor. So if I open up here and select the one I want, we'll say the visual only actor. And with that selected, we'll go back to the property matrix and click this little arrow. And now the 3 test assets, which were just duplicates from these assets, have been updated to all point to the same actor class to spawn. And so I'll click those three and save. And now we've updated all those data assets without having to do any sort of data inheritance. So in summary, data assets have a slightly different workflow than normal Blueprint classes. You can create a new data asset class type by subclassing UDataAsset. Blueprint can create data asset instances to populate the variables of a data asset class. Data asset instances are essentially singletons in memory at runtime, and modifying one will modify for all users of that data asset instance. Blueprint can extend a data asset C++ class to add variables if your data asset is blueprintable. They can extend it via the Blueprint class inheritance. Data assets are a convenient way to share data across multiple classes, like custom actor spawners made here. You need only update the data asset, and all the spawners in the level will use the updated data without requiring any manual tweaking. I hope that helps. Let me know if you have any corrections, concerns, or questions in the comments. Until next time.